Hi folks, and welcome back to the Astroforum channel. My name is Wido, and in this video I'm going to talk about auto-guiding. First, I'll explain what auto-guiding is and why you probably need it for astrophotography. Secondly, I'll give you some tips on how to select a good guidescope to start auto-guiding. And I'll show you some guidescopes and cameras that are on the market today. So let's dive right in. So why do we need auto-guiding? Well, in my earlier videos I already talked about the importance of buying a good equatorial mount, as this is probably the most important piece of equipment you'll need for your astrophotography with a telescope. A good equatorial mount is able to accurately track the apparent movement of objects in the night sky caused by the rotation of the Earth. But however good these equatorial mounts are, they are not perfect in their tracking. Even the best equatorial mounts, they will show some mechanical imperfections in either their gears or their bearings, and those imperfections they will result in tracking errors. So when we take long exposure pictures, these tracking errors lead to elongated stars and smeared deep sky objects in our images. When you take multi-minute exposures, most mounts they will need some help to accurately track the objects in the night sky, and this is actually where auto-guiding comes in. So what is auto-guiding? Well, auto-guiding basically involves the application of small corrections to the position of an equatorial mount when taking long exposure pictures of the night sky. So in the past those corrections were actually made manually by the astro imager. But in the age of digital cameras and computers, guiding is now accomplished automatically, thank God. So a camera and some specialized software, mostly PhD2 guiding, they can monitor the position of a star nearby the object that you are imaging. It will then send small corrections and nudge your mount automatically to keep the position of the star in the same position. And this is actually what auto-guiding is all about. Now, if you're taking very short exposures of bright objects like the moon or the planets, you don't actually need auto-guiding during your imaging session. But if you're planning on capturing weaker light from most deep sky objects outside of our solar system, you're definitely going to take multi-minute exposures to capture the faint light from those objects, and auto-guiding will become a necessity. Auto-guiding only works when your mount is already properly polar aligned and correctly operating. So if you're unsure what polar alignment is or how to polar align your mount, you might want to check out a video, I will link to it in the description below, where I explain how to polar align an equatorial mount. Also, auto-guiding, it cannot correct for sudden errors in tracking by, for instance, a poor quality equatorial mount, or by sudden errors caused by, for instance, strong winds. Also important, auto-guiding can only be used in combination with an equatorial mount, and it cannot correct for the field rotation caused by tracking with an ALT-S, or an altitude azimuth mount. Altitude azimuth mount. So what gear do you actually need for auto-guiding? Well, there are several options to auto-guide an equatorial mount, and the two most often used methods are to auto-guide with a separate guidescope and a separate camera attached to that guidescope. But another method is to use a so-called off-axis guider. And this off-axis guider, it splits light collected by the main telescope to a separate camera, and that guide camera can detect and track a star somewhere within the same field of view as the main object that you are imaging. Well, there are pros and cons to each of those guiding methods. In this video I will focus on the first option, to guide with a guidescope and a guide camera. Using a separate guidescope and a separate camera is, I think, ideal for beginning imagers. From my personal experience, I can tell you that this method works very well with a telescope that has a focal length up to 1000 or even 1500 millimeters. And I will get into the kind of guidescope that you'll need, and after that I will discuss guide cameras. Question of the day: what kind of guidescope and camera are you using for your astrophotography? Please leave a comment in the comment section below so we can help each other out and give each other more information on this topic. So what kind of guidescope and guide camera are you using for your astrophotography? Thanks! So what kind of guide scope do you need for auto guiding? Well, you need to take several things into account when selecting a good guide scope for auto guiding. I would say the first thing to take into account is the aperture and the focal length of the guide scope. So you might be tempted to choose a guide scope with a large aperture and a long focal length. A larger aperture translates into a higher resolution, and this enables you to detect fainted stars in nearly any field of view anywhere in the sky. And of course, a longer focal length, it allows you to really zoom in and detect small displacements in the position of your guide star. However, there are some additional concerns beyond the aperture and focal length you definitely should take into account. And most importantly, I'm then talking about weight and size. So larger apertures and focal length telescopes, they are also heavier and larger in size, of course, and you don't want to select a guide scope that is too heavy, as it will tax the mount in its tracking capability. Also, a longer focal length telescope, it can introduce some flexure in the tube that is different from the flexure of the main telescope you're imaging with. You don't want that, as it leads to tracking errors. And you want also a sufficiently wide field of view, so a shorter focal length, to detect a larger number of potential stars that you can use for your guiding. So yeah, you will still ask me what is a good focal length and aperture for a guide scope. So hi folks, let me quickly explain how you can calculate your preferred focal length for your guide scope and your guide camera combination. I am using astronomy.tools for this. It's an extremely useful website if you ask me. When you click on field of view and imaging mode, you'll get to this overview. I'm going to select a random Messier object because it doesn't matter for this particular example. And let me give you some personal figures here. So as a telescope, I am often using my 480 focal length and 80mm aperture apochromatic refractor. And as my main imaging camera, I am often using my ASI 1600 Mono Pro. Let's see if we can find it. Yeah, it's here, which has a pixel size of 3.8. Importantly, this will give me a resolution of 1.63 arc seconds per pixel. So you should write that down somewhere. 1.63 arc seconds per pixel, and remember that particular number. So now I'm going to calculate the resolution for my guide scope and my guide camera combination. So as a guide scope, I'm still using a very cute small 50mm Orion guide scope, which has a focal length of 162mm. I will talk about this telescope later on in this video. And as a guide camera, I'm still using my ASI 120 camera here, which has a pixel size of 3.75. And I will discuss cameras also later on in this video. But what is important for now is that this camera and guide scope combination, it gives me a resolution of 4.77. And now you can of course simply divide 4.77 as a resolution of my guide scope and my guide camera. I divide this by 1.63, which is the resolution of my main telescope and my main camera. I'm getting the multiplication of about 2.9, so about 3. And as a soft rule of thumb, I would advise you to select a guide scope and a guide camera combination that does not exceed 5 times the resolution you're getting from your main telescope and your main camera. So a final thing to take into account when selecting a guide scope would be that the guide scope also has a solid focuser, so that you are able to hold the guiding camera in place and keep it from moving around during an imaging session. Also a good high quality mounting ring and an adequate dovetail rail. It really helps you to mount the guide scope solidly on your main scope, and this will also lead to less errors in your tracking. So let me show you 4 interesting guide scopes that are available on the astrophotography market today. This is by no means an exhaustive list, so always do your own research. And if you're interested, links to the guide scopes, you can find them in the video description below. So let's dive right in. The first one I want to show you is the Orion Deluxe Mini 50mm guide scope, and I've actually owned this guide scope for many years myself. It has an aperture of 50mm and a focal length of 162mm. I have used this Guidescope in combination with my 500mm focal length refractor imaging telescope, and also with my Edge HD at a focal length of about 1500mm. And actually I was very surprised to see that even at 1500mm focal length, when I was taking 5-minute pictures, 5-minute exposures, I still got nice round stars in my field of view. So I was pretty impressed with this little Guidescope, especially also considering the price of about $100, so it's very affordable. It comes with a helical focuser, so it's very easy to focus your guide cam on a star field. Also, you have this little bracket. You can mount it on top of your main telescope. Yeah, of course, it doesn't include any dovetail rings or a dovetail bar that would make it even more solid. But actually, I never experienced any issues with this little bracket. Yeah, I think this is probably because the telescope is so lightweight at just about 1.2 pounds or half a kilogram. You can also look at the bigger brother, I would say. The Orion 60mm Guidescope is available for $170 more or less on the market. It has a 60mm aperture and a 240mm focal length. So if you're a little bit unsure about the short focal length of this Guidescope, you can buy the 60mm to 40mm focal length Guidescope. Yeah, if you have maybe a reflector or a Smith-Cassegrain telescope and you want to combine it with a Guidescope that has a longer focal length. Yeah, it also comes with a helical focuser, and especially another difference is that it comes with two solid rings here and a dovetail mounting bar. So yeah, you can really securely fix or mount your Guidescope on your main rig without any issue here. The price is also $170, so you will pay not twice as much, but almost about twice as much as the Orion 50mm Guidescope. The weight is 2 pounds or about 1 kilogram here. Then we have a very similar scope. It's from Prima Luce Lab, and actually I'm suspecting that maybe it comes from the same factory, but I'm not sure. At about $185 you have the 60mm compact Guidescope with a focal length also of 240 millimeters and an aperture of 60. It also comes with a helical focuser, 2 telescope rings. It will also come with a solid dovetail mounting bar, and it also weighs 2 pounds or 1 kilogram. So now, as for thinking a little bit outside of the box, I have this Skywatcher EvoGuide 50 ED Guidescope, the second version, for $425. So you probably will say, hey Wido, are you insane recommending this as a Guidescope? And I would say, yeah, as a Guidescope, yes, I would be a little bit insane. But please keep in mind that this telescope has a very high quality FPL 53 glass. And it's actually a doublet, so it has extra dispersion glass. It has 2 pieces of glass in front of the telescope, and this provides a pretty good color correction, meaning that you can also use this telescope as a little telescope for imaging. So if you're interested in also shooting some wide field pictures from time to time, you can actually use the Skywatcher EvoGuide as an imaging telescope as well. So that might be interesting if you want to, also want to do some wide field astrophotography. It also comes with 2 telescope rings, a helical focuser, Vixen style mini dovetail, as you can see here on the picture. And what is also very interesting is that it is super lightweight at about 0.9 pounds or 0.4 kilograms. So you will really limit the weight put on your equatorial mount. So let's also talk about selecting a good guide camera. Well, first of all, a guide camera doesn't have to be as sophisticated as your main imaging camera, but there are a couple of things you want to take into account when selecting a guide camera. For instance, you want to consider a monochrome camera for guiding. When guiding, you actually don't need a color camera, and the Bayer matrix in front of the sensor of your color camera, it can actually cause some loss of resolution and sensitivity. Also, you want a camera with relatively low read noise and minimal hot pixels, so that the guiding software doesn't mistake them for stars. What is also useful is to have a compact, lightweight guide camera to minimize the weight on the focuser of your Guidescope. And you probably also want a good USB connection. So 2.0 at minimum or faster for a good fast data transfer. And finally, this is a little bit debatable, but most of the guiding cameras, they have also an ST4 guiding port. And this is useful if you want to connect your camera directly to your equatorial mount. There is a more popular option and a better option in my opinion, and that is to use an ASCOM software, an ASCOM driver, where your computer or laptop communicates with the mount directly. But it is nice to have an ST4 guiding port as a backup, so just in case your ASCOM driver fails for some reason. And finally, I would also emphasize you don't need a large sensor camera. So small sensors combined with a Guidescope that has a modest focal length, this is already enough to pick up enough potential stars for your guiding in your particular field of view. Let's also look at some interesting guide cameras that are on the market today. Again, this is not an exhaustive list. Always do your own research and you can find links to the cameras in the video description. So let's start with the most popular camera, the ASI 120 monochrome mini guide camera. A lot of people use this one. It has a pixel size of 3.75, so it's pretty small pixel size, and that enables the camera to detect very small variations in the movement of a guide star, and it will then send, of course, corrections to your equatorial mount to keep the guide star in its original position. So that's pretty important. It has a high quantum efficiency of 80%, so it's also able to detect fainter stars in a field of view, so that's pretty nice. The resolution is 1280 by 960. Well, that's not the best, but at the same time I would say when you combine this guide camera with a short focal length Guidescope, such as the 50mm Orion Guidescope, which has a focal length of 162mm, you're still able to detect enough stars in your field of view that you can potentially use for auto-guiding. The read noise is a little bit on the high side but at the same time, I have actually guided with the 120MC camera and I never experienced any issues in hot pixels or anything like that. So definitely this camera is good enough. It has a low enough read noise to be used for auto guiding. The frame rate per second is 35. Nothing to write home about, but at the same time, when we are auto guiding, we often use exposures of about 1 second to track a star in the night sky, so the FPS is definitely not an issue. The USB 2.0 is fast enough to communicate between the camera and the mount. And then the analog to digital converter is 12-bit, the full well capacity is 13K. Well, that's nothing to write home about again, but actually you can use this camera for some basic moon and planetary imaging as well, so that's nice. The ST4 guide port is included as well. Most of us use ASCOM drivers, so we don't use the ST4 guide port, but it's always nice to have this port as a backup, just in case your ASCOM driver fails. You still have an alternative way of connecting the camera to your equatorial mount for auto guiding. So I should say that QHI often has very similar cameras with the same sensor. So in this case it's the QHI 5L2 monochrome camera at $169. The same pixel size. Quantum efficiency is a little bit less at 74%. Resolution about the same. Read noise is exactly the same. The FPS is about the same. Also USB 2.0. ADC and full well capacity are the same, and it includes an ST4 guide port. So basically I would say also check the availabilities of these cameras. I think QHI is also a good brand camera that a lot of people use in astrophotography, so I would just check whether or not both cameras are available, and I would just compare the prices to decide which one you would like. Now I do have to mention that for each of these guiding cameras you also have a regular camera. So in this case, this is the ASI 120 monochrome planetary camera, so this is not particularly a guide camera, but you can use it for guiding as well. So you can see it has a lot of the same features. The main differences are that this camera has a higher frame rate per second, 60 FPS. This is not important for auto guiding, but it is important when you want to use this camera also for moon and especially planetary imaging. So if you're considering to use your guide camera also for planetary imaging, I would definitely also consider the regular ASI 120 monochrome. It has a 3.0 USB, so that's why also the FPS is a little bit higher at full resolution. The analog to digital converter, the full well capacity are exactly the same, and it also has an SD4 guide port. So let's look at a more expensive camera. So this is the ZWO ASI 290 monochrome mini guide camera. It has a smaller pixel size as compared to the 120 2.9. And of course then you are able to detect even smaller variations in the movement of a guide star. So that's pretty nice. It will send corrections to your equatorial mount. High quantum efficiency, actually it's about the same as the 120 guide camera, so no differences there. It offers a higher resolution at 1936 times 1096. But at the same time you have a lower pixel size, so you will end up with about the same star field as compared to the ASI 120. It does have a much lower read noise, so that's nice. Frame rate per second is 20, but as said, you mostly tracking guide stars at about 1 second exposure, so that's no issue. It has a USB 2.0, a full well capacity that is a little bit higher, same 12-bit analog to digital converter, and it includes an SD4 guide port. Yeah, of course you also have the regular version then of the ASI 290 monochrome, and the main difference again is the frame rate per second and the USB 3.0 connection. So you have here a frame rate of 170 instead of only 20 with the guide camera, because of the USB 3.0 connection. And you really want to think about, hey, do I want to use my guide camera also for planetary imaging? If that is the case, you want to consider maybe the regular ASI 290 planetary camera. Of course, QHI has its own version, the 5.3 290 monochrome camera. Again, this is the same sensor, so we're looking at the same pixel size, quantum efficiency and resolution, low read noise. About the same frame rate per second. Also it includes USB 3.0, same analog to digital converter and full well capacity, and it has a Lemel style guiding port, so that's a little bit different in the QHI, so it has a different guiding port, but in general both of them of course can be used. And as I said before, you might want to check which camera is readily available here. Final camera I want to mention is the ZWO ASI 178 monochrome camera. And actually this is because I own this camera myself for planetary imaging and yeah, some lunar imaging. You can see that the pixel size is an impressive 2.4, so it has a very small pixel size. So again, this allows you to detect very small differences in the movement of a guide star, so the camera is able to send corrections to your equatorial mount a little bit earlier as compared to the other cameras I showed you. It has also a quantum efficiency of 81%, so yeah, that's about the same. But the big thing is that it also comes with a much higher resolution of 3000 by 2000, so you will be getting a little bit of a wider field of view. And when you have a wider field of view, of course, you can detect more stars, so you can also detect more potential stars that are fit for auto guiding. It has a pretty low read noise at 1.4, 60 frame rate per second, 3.0 USB connection, and also the analog to digital converter is 14-bit instead of 12-bit. Full well capacity about 15K, and it includes an SD4 guide port. So I would say this is a high level camera that you can use for planetary imaging as well as guiding. So that's maybe something you should take into consideration. Of course, you have the QHI 53178 version of it, of course with the same sensor and basically the same features. yeah, almost no differences here. So again, I would just look at, hey, which one of the cameras is readily available and compare the prices to decide which one you would like to buy. In this video I mainly talked about gear, so guide scopes and guide cameras. So in my next video I will get into how you can put it all together. I'll get into details on connecting your camera using computer software like PhD2 that can actually monitor the signal from your guide star generated by your guide camera, and it can actually calculate guiding errors and send corrective signals to your mount. So anyway, that's for the next video. I hope you like this kind of content about astrophotography. If you do, I hope you'll subscribe to my channel, of course. Links to all of the Guidescopes and cameras are in the video description below if you're interested. Thank you so much for watching, and clear skies!